So today we're going to be looking at distance from a point to a line. For our notes, we are still in Unit 2. We are on day 7. A little bit. Finding the distance from a point to a line is what we're going to be doing. So when we're finding the distance from a point to a line, we always want to find the shortest distance. Okay, if I wanted to know how far am I from the wall that has the screen on it, I wouldn't measure at a weird diagonal to see how far I am from that wall, right? I'd measure straight to that wall at a 90-degree angle, okay? Same thing if it's kind of hard to see that little picture, but we have this little mouse, and the little mouse wants to get to the cheese stick, right? And it's not going to think I have to go to the end of the cheese stick to open it because the mouse is just going to bite through that plastic, right? Wherever it is. So which direction is the mouse going to go? Is it going to go up? Is it going to go perpendicular? Or is it going to go to the other end? Yeah, it's going to go it's like, I want the cheese. I'm going to go the shortest distance. So it's going to go the shortest distance, which is always going to be the perpendicular distance. Okay, so the mouse is always going to go perpendicular to the cheese. What's the symbol for perpendicular? Yeah, the upside down capital T. So we are going to be using graphs. When you walked in, I did give you some scratch graph paper for when you get onto Schoology and you do the assignment, because it's really easier if you can physically graph these problems to try to figure them out. Okay? All right, so number 1, we're going to find the distance between M, the mouse, which is at 1, 5, and a line that contains the points C at 0, -2, and H at 6, 6. So that line is like our cheese. Okay? So for our line is the point 0, -2. So 0, -2. And then that's point C. And then H is at 6, 6. So all the way up here in the corner. And that's point H. Okay? My mouse is at the point -1, 5. -1, 1, 2, 3, 4, 5. Here's my mouse. Okay? The first thing I'm going to need to do is I need to figure out what is the slope of this line that would contain C and H. Okay? So I'm going to use my slope formula to find the slope between points C and H. So when I do that, I know I'm going to be subtracting my y's and subtracting my x's. Here are my 2 points. Which y is going to go first? 6 minus -2. So 6 minus a -2. And then, which x value has to go first? The 6. We're starting with the second point, and 0. So my slope is really 6 plus 2, which is 8. And then 6 minus 0 is 6. So 8 over 6 reduces to 4 over 3. So that's my slope, and you can check to see if you did it right, because if from point C I go up 4 over 3, and then I go up 4 over 3, you can see I land right on H. Or I could go down 4, back 3, so that I can see this is the line that is the cheese.
Should I write that?
That this is the line that is the cheese?
No, like the picture.
Yeah, I would draw it. Yeah. Okay? So that's step 1, is just to figure out the slope and make sure you have the line. Step 2 is going to be to find the perpendicular slope. So if my cheese has a slope of 4/3, what's the perpendicular slope? Yes?
-3/4.
Perfect. -3/4. Okay? So then from point M to the line, we're going to use that slope until we intersect the line. Sometimes you just do it once, sometimes you have to do it a whole bunch of times. So from M, we're going to go down 1, 2, 3 over 1, 2, 3, 4, and we can see we land on it right here. So this is the perpendicular distance because these two, the segment that I just drew and the orange line, are indeed perpendicular. Does that make sense? So now what I have to do is I have to figure out what is the length of this segment. Okay, sometimes I'll think of this, even though they didn't name it, I'll think of this as point P. It's where the perpendicular intersection is. But you can call it whatever you want to call it. But I have to figure out how long is MP, or whatever you call that other point. Okay, how long is that segment? So I have a couple of options. I can use the distance formula, where M is at -1,5 and P is at 3,2. Or I could think back to a while ago, and I could use that slope where we went down 3 over 4, and I can see that I make a little right triangle. And when I make a little right triangle there, I can see one of the vertical sides of that right triangle is 3. The horizontal side is 4, because that was our slope. And I need to find this distance here, which is like my hypotenuse, my c squared. Do you remember Pythagorean Theorem?
I just saw a TikTok about this. Yes.
Y'all just had a big talk about Pythagorean Theorem?
No, like on TikTok there was this talk about the Pythagorean Theorem, like this guy solving it on the SAT.
Ah, nice. All right, so once you have your right triangle drawn, then you just put 3 squared plus 4 squared equals c squared. 3 times 3 is? 4 times 4 is? That equals c squared. 9 plus 16? 25. How do I get rid of a square? We square root. Because squares and square roots cancel. Square root of 25 is 5. And really in Algebra 2, we learned that the square root of 25 is plus or minus 5. But since we're talking distance, it's just a positive. Because in geometry, we like to be positive. So the distance between M and the line is 5 units. So, again, the first thing we do is find the slope of the line. Second thing is find the perpendicular slope and then draw it until it makes a segment. And then we make a right triangle, and then we apply the Pythagorean Theorem. If you just want to use the distance formula, the square root of x1 minus x2 close parentheses squared plus y1 plus minus y2 close parentheses squared, you can use your distance formula. It works too. But I think this is a little easier. All right. Example 2, find the distance between M1, 1 and a line that contains C2, 4 and H5, 1. So first I'm going to graph my line and find its slope. So C is at 2, 4. H is at 5, 1. My slope of the line, what's going to go in my numerator? 1 minus 4. What's going to go in the denominator? 5 minus 2. 1 minus 4. 5 minus 2. So that's going to be negative 1. And so we can see I can go down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1, or up 1, back 1, up 1, back 1. There's my line. Line CH. Okay? I didn't label C and H. I probably should have. C and H. All right, so then the next thing I'm going to do, my mouse is at 1, 1. So I need my perpendicular slope to get my mouse to the line. Perpendicular slope. What is the perpendicular slope of negative 1? 1, positive 1, right? Because this is negative, this is going to be positive. 1 is really 1 over 1. When you flip it over, it's still 1 over 1. So just a positive 1. So from M towards the line, I'm going to go positive 1 over 1, positive 1 over 1, and I can see my other little intersection is right there. Okay? So then for my right triangle, now I went 1 over 1, and I went 1 over 1, but we don't want to do like too little, right? We don't want to have to do the Pythagorean Theorem twice. So we're just going to fill in, if we go all the way up and over, like 2 over 2, which is still the same slope, right? That makes my little right triangle, where I've got a 2 and a 2, and I need to find the hypotenuse. We're always going to be finding the hypotenuse, so that's kind of nice. Later in there when we do right triangles, sometimes we have to find legs. But today we're always finding the hypotenuse. So a squared plus b squared equals c squared, where both a and b happen to be the same. They're both 2. 2 squared is 4. So 8 equals c squared. How do I get rid of the square? Square root. So if I do the square root of 8, let me grab a calculator. A new document. Don't save whatever's going on there. And a graph. Nope, I don't need a graph. I need a calculator. The square root of 8. How many places do you think I'm going to say we should round to?
3.
3. Perfect. So the distance is going to be 2.828 units. Questions? All right, that's really all there is to it. It's really that simple. Let's look at the next one. We've got two more examples. Oh, be careful with my points. I should have paid more attention when I printed them out, that negative, and then it falls over to the other side on both this example and the next example. They're all example 1s. I should have paid attention to that too. All right. Example 1, the third example 1. Find the distance between M, 3, 7, and a line that contains C, -4, -2, and H, 2, 0. All right, so first thing I'm going to do is graph the cheese. -4, -2, and 2, 0. And if I look at my slope for that, this was C and this was H. What am I going to put in my numerator? 0 minus -2. And in my denominator, 2 minus -4. Equals 0 minus a -2 is 2. 2 minus a -4 is 6, because it's really adding. 2 over 6 is 1/3. And we can check that. If I start at C and I go up 1 over 3, up 1 over 3, up 1 over 3. The more dots I have, the easier it is for me to draw the line. I don't know about you guys. Especially when I didn't get rulers out for us. Beautiful. Okay, now where is my mouse? My mouse is at 3, 7. Here is my mouse. What's the slope I'm going to use to get from the mouse to the cheese? -3. So I'm going to go down 1, 2, 3, over 1. Down 1, 2, 3, over 1. Did I get off a spot? Should have lined up. Oh, up 1, over 1, 2. Yep, I got off a spot. My other point should have been there. I didn't count over 3. So it hits the line. Whew. Okay. then I'm going to make my right triangle. I'm going to come down not all the way to the orange line. I'm just going to come down till when I can switch to horizontal. It'll make a right triangle. This graph is a little bit difficult to graph on. Sorry about that. How far down am I going if I went down 3 over 1, down 3 over 1? Then a total of, how far total down did I go? I went down 6, and how far over did I go? I went over 2. So my A and my B are 6 and 2. A squared plus B squared equals C squared, 6 and 2. It doesn't matter which order you put the 6 and 2. I could do 2 squared and 6 squared. I'm still going to get the same thing. 6 times 6?
36.
2 times 2?
4.
36 plus 4? And again, if I had switched those, I'd have just ended up with 4 plus 36, and I'd still end up with 40, right? So that order doesn't matter. We're going to square root, and then we'll round to how many places? 3 places. The square root of 40, rounded to 3 decimal places, is 6.325 units. All right, one more example, and again, we have this negative in point C that kind of fell, the point kind of fell over on the line. So when I graph that point, I need to make sure that I remember C is at negative 5, 3. And H is at 4, negative 6. So my slope, because if I can find shorter places to put points in there, that's going to be easier to draw that line. What am I going to subtract in the numerator? Negative 6 minus 3. And the denominator? 4 minus a negative 5. Negative 6 minus 3?
Negative 9.
4 minus a negative 5?
Negative.
Positive 9. So that's going to be a negative 1. So down 1 over 1, down 1 over 1. The whole way. There's the cheese. It must be like cheddar because I went with orange. Okay, and then my mouse is at 2, 4. Here's my mouse. What is the slope I'm going to use to get from my mouse to the cheese? Positive 1, because negative 1 becomes positive, and then you flip it over, 1 over 1 flips to also 1 over 1. So positive 1. Now, if I start at M and I start going in the positive direction, that mouse is going away from the cheese. So instead of going up 1 over 1, up 1 over 1, up 1 over 1, what do I have to do? Yeah, down 1, back 1. It's still a positive slope, right? Still a positive 1 slope. So then when I make my right triangle, I'm really going down to the axis and over. Here's my right triangle. How far down did I go?
4.
4. How far over did I go?
4.
4. So my A squared plus B squared equals C squared. A and B are both 4. 4 squared is 16. And 16 plus 2, or 16 plus 16? 32. And then what do I do? Square root, because squares and square roots cancel out. Square root of 32. Let's grab our calculator. Handy dandy calculator. Square root of 32, rounded to 3 decimal places, is 5.65. Is that a 6 or a 7?
7.
7. units. Okay.
Can you go back up to the first, or not the first one, the last one again?
Yeah. And tomorrow we will have a quiz. Tomorrow it will be open notes, so you can use all your notes on the quiz tomorrow. If you've missed any of the notes, they're all in Schoology, so you can always go back in and look in Schoology to get all of those notes.